Everybody. Thanks for joining today. Today's topic is hybrid cloud disaster recovery and how you can deliver rapid recoveries in AWS Cloud. I'm Chandra Reddy. I'm the AWS Storage and Data Lake Specialist. With me, I have Rick Vasquez. He's the AWS Solution Architect Specialist for VMware Technologies. And I have Alan Henderson. He's the AWS Storage Solution Architect Specialist. The agenda for today is why should you consider hybrid cloud for disaster recovery? And then we will go through a couple of concepts or various technologies that are available to achieve hybrid cloud disaster recovery. Could be using backup technologies, or could be an AWS CloudEndure, and we'll also look at some pricing scenarios, and of course, VMware technologies and some pricing scenarios. Along the way, if you have any questions, please don't wait till the end of the webinar. Ask your questions in the chat window. Rick and Alan will try to respond them in real time. And for those questions that we can't get to in real time, we will definitely consider them at the end of the webinar. The goal is to present in 30 minutes and leave 15 minutes for Q&A at the very end. All right, so let's start with what are the major disaster recovery causes? The first one that's very concerning right now, especially in the last, I would say, 18 months or so, is ransomware. As you can see here, clearly the ransomware attacks have been on the rise, and 2021 is kind of breaking all kinds of records when it comes to these ransomware attacks. Definitely a big challenge. There are two types of ransomware infections that could happen. One is it can lock your employees from getting into their workstations, so their productivity gets impacted. And second, the more dangerous one is silent encryption of your data over a period of time, and then they hold a ransom, to decrypt the data. So, how do you recover from that? And we should treat ransomware infection as a disaster, and hence we'll consider that as well in our topic today. The second one is extreme weather patterns that we are seeing. This is not a picture of Aspen, Colorado. This is actually Austin, Texas, back in February, where we had 7-degree Fahrenheit temperatures, never seen snow in Texas. And of course, all of this led to power outages and data center outages. Many organizations in Texas especially got impacted, where they could not even get to their DR data center because they ran out of fuel for power for generators in the second data center. So more such weather patterns we are clearly seeing. Canada had 120-degree Fahrenheit this summer, more hotter than Texas. So very unpredictable. So we gotta protect ourselves from both, man-made disasters as well as natural disasters. And that's the main topic today. So what are the challenges with disaster recovery within data centers? Like for many, many years and decades, this has been a popular architecture where applications in the production data center are being protected, backed up, or replicated to a second data center. Could be a co-location or your own data center. The challenges here is that if you think about the amount of infrastructure that you need to allocate in your offsite data center for DR purposes, you not only need just storage to store the data, but you need compute to run either backup software or replication software. You need some sort of hypervisor. So you need to pay for all of this infrastructure 24/7. And there is a massive capital expense typically. And then, of course, there is more infrastructure such as SAN switches or network switches, firewalls, bandwidth, space, and power. All of this adds up. And the challenges is you got to keep patching all these systems, right? And then capacity management has always been a huge burden. As organizations grow, they add more workloads, the data grows, and whatever the design was in place does not scale linearly. And capacity management is a major challenge. And when you set up this infrastructure, typically you would buy more than what you need, and that causes underutilization for significant amount of period. And hardware refreshes become really expensive. And then, of course, there is operational burden to manage all of this. Fortunately, there's a better way to do this, and that's what is the topic today. How can you modernize your disaster recovery? So the idea here is to come up with a hybrid cloud disaster recovery architecture so that your on-premises workloads can be backed up and or replicated to AWS Cloud, where you can use almost infinite storage that's available for you And then on demand, you can do recovery. So you don't have to assemble all kinds of compute, hypervisor, storage, network infrastructure. It's all built for you and you pay as you go. So that's the hybrid cloud DR architecture. The benefits of this architecture is clearly a lot of the backup and disaster recovery technology software vendors out there. They have an AWS first strategy, which means that anytime they want to add new functionality, they first think about integrating with AWS. So you all benefit if you have been using those third-party independent software vendors. AWS offers almost infinite storage with industry-leading durability and availability. It's unmatched, so that ensures that you have the peace of mind that your data is safe and secure in AWS Cloud. You have almost zero operational burden on a day-to-day basis because the storage can grow and shrink on demand based on how your backup or replication software is using it. You can grow and shrink capacity and you can pay per use, which means that you don't have to suffer through very high expensive hardware refresh costs. And all of this can be kind of translated. If you look at your cost curves, the blue curve here is if you were to do on-premises to on-premises DR costs. Because of all the aspects that I just mentioned, you need to assemble compute, storage, networking, firewall, space and power. All of that upfront is kind of a static allocation of cost. And then over a period of time, you start consuming. Whereas in a hybrid cloud DR cost, the costs are pretty low in a steady state situation, and the costs spike up only when you actually do a disaster recovery. And that's when a majority of your compute gets consumed. And then it goes away as soon as your DR is over or your DR testing is over. Many of our customers also use this actually to do their test and dev practices as well. If their test and dev or UAT testing, as an example, needs a sudden spike in the amount of servers that they need to test, they also use the same methodology, which is recover their servers in AWS and do it for test and dev purposes. All right, so let's dive a little bit more deeper. So how do you do DR from on-premises to AWS? But before we go there, let's look at like the two basic important concepts of disaster recovery. Recovery time objective. It's all about how quickly can you recover, which means the lower the RTO, the better it is for you. Right? And then there is the second concept of recovery point objective. The idea here is that if you're using backups or replication, could be continuous data protection or could be snapshot-based replication. Either way, there are discrete points in time where you're sending the data over to AWS Cloud, and which means that it could be like seconds or minutes or hours or even days. So assume that it's 1 hour. Every 1 hour you're sending data to AWS Cloud. So your data loss window is 1 hour. And that is what I mean by recovery point objective. Obviously, the lower the RPO, the better it is for you because it reduces your data loss window. We are going to walk through these 5 different disaster recovery methods that can deliver you with various RTO and RPOs. As you can see, there's a legacy backup technology that can give you 24 hours of RTO and RPO. Modern backups will reduce the RTO. AWS CloudEndure can reduce the RTO and RPO to minutes. And then we'll talk about 2 technologies within VMware that can reduce your RTO and RPO. Okay? So let's start with the legacy backups. Think about recovering from backups. Here's the Gartner's Magic Quadrant from a backup technology vendors. These are the top 7 vendors in the leaders quadrant. All of these vendors have deep integration with AWS, and they have been sending thousands of petabytes to AWS every year. When I say thousands of petabytes, this is after compression and deduplication. Thanks to deduplication and compression technologies, this is just thousands of petabytes. The actual data protected, if you consider the retention of typical 30 days, this easily runs into exabytes of data that comes into AWS every year. So the idea here is that they send the data into AWS, store the data in a scale-out, almost infinite storage, S3, which is an object storage, and then perform on-demand disaster recoveries in AWS. So here is how a recovery scenario would look like. So first, let's start with the backups. On-premises, you use your favorite backup technology to store the backups on-premises, replicate the data to S3, which is a scale-out object storage in AWS. And then, your backup server, on-demand backup server, could rehydrate the data, which means restore the data from S3. It may have to uncompress and undedupe the data and restore it to on-demand to EC2 instances, right? So most of the backup vendors can actually convert their on-premises VMware VMs and Hyper-V VMs and physical servers as native EC2 instances. So this is one way. The second approach is to actually recover them as a VMware virtual machine in VMware Cloud on AWS. The benefits of this approach obviously is very low 24/7 steady state cost because you're just paying for object storage, which is very inexpensive. And you pay for compute only when you do the recoveries. The disadvantage of this approach is large RTO and RPO, typically 24 hours with the legacy backups. Now, some of the backup vendors have recognized this, and they have innovated to reduce the RTO for you. And here is how they do it. So from some of the modern backup vendors, what they do is that, of course, they store backups on premises as well as in S3. But behind the scenes, based on your policies for specific VMs that you apply in the policy, they will actually rehydrate the data after each incremental backup and store them as EBS snapshots in AWS. The benefit of this approach is that when you try to do recoveries, you don't have to rehydrate the data like the previous slide. Here, the backups are also being stored as EBS snapshots as an option. And then when you do the recoveries, you're just mounting from these EBS snapshots, and the EC2 instances come up almost within minutes. And in the background, the data will be restored from these EBS snapshots back to the EBS volumes here. So the data is almost instantly accessible. There will be some, I would say, latency when you are accessing the data if it is not already restored to the EBS volumes, but behind the scenes, asynchronously, the data is being restored. So reduces your RTO, that's the advantage, and keeps the cost low because steady state, you're just paying for the backup stored in S3 and the EBS snapshots. You're not paying for this compute. You're paying for this compute only when you actually recover. The RPO is still large because chances are very high you're sending backups only once a day. Could reduce it to 12 hours as well, and some could also reduce it to 4 hours, but it's still not in minutes. So we covered legacy backup technologies and modernized backup technologies. Could be any of the ISV software vendors that I mentioned in the previous slide. Let's talk about what if you want RTO and RPO in minutes, much more aggressive RTO and RPOs for some of your workloads. This is not a replacement for your backup technology. AWS CloudEndure, replication and disaster recovery, I would consider this as augmenting to your as an augmentation to your backup technology. Please continue to do your backups, and on top of it, recognize your mission critical important workloads and use AWS CloudEndure. So how does it work? So let's walk through the details. Here is how we can reduce RTO and RPO with CloudEndure. So first thing is, in your production data center, whether it's physical servers or virtual machines, you deploy CloudEndure agents. These agents basically keep track of change data blocks. As in when the data is changing, your application or users are writing, we keep track of change data. And asynchronously, this data is being replicated to lightweight replication servers. This is part of AWS CloudEndure service. You don't have to worry about this. AWS takes care of this. The replication is asynchronous, which means as soon as the data is changed, we'll try to replicate those change blocks over to these lightweight replication servers in AWS. This kind of reduces your RPO to seconds or minutes, right? Depending on the change rate, the amount of data is changing, and the bandwidth you have, and the latency you have. It could vary from seconds to minutes. But once the data is here, in the background, what we are also doing is you can take snapshots. Again, this is part of our service. These snapshots can be as aggressive as every 10 minutes, or you can take snapshots every 1 hour, or you can take snapshots every 24 hours. It's totally up to you. So the higher the frequency of snapshots, the lower the RPO. So if you take a snapshot every 10 minutes, you get an RPO of 10 minutes. If you take a snapshot every 1 hour, you get an RPO of 1 hour. So you can totally dial and control your RPO from minutes to hours using CloudEndure. And then at the time of recovery from these snapshots, essentially, we will recover it as a native EC2 instance. And this is almost instantaneous, as I explained in my previous slide. These are native EBS snapshots. You can access the volumes immediately. The data will be restored behind the scenes from the snapshots to the EBS volumes. So this is how CloudEndure reduces your RTO and RPO, right? So that's the benefit. The disadvantage as compared to the backups is that relatively higher cost than performing disaster recovery from a backup technology. And the reason is there will be some staging costs because of these replication servers, some staging EBS volumes and EBS snapshots. But then, of course, you're not paying for this compute. You pay for this compute only when you do these recoveries. Okay, so this is how you reduce your RTO and RPO with AWS CloudEndure. At the risk of repeating myself, I want to emphasize that this is in addition, use this in addition to your backups that you are using. This is not a replacement for your backups. The AWS CloudEndure has a very wide platform support. As you can see here, many applications, databases, physical servers, virtual machines are supported. Even workloads that you have maybe in a different cloud can actually be replicated to AWS and recovered in AWS. Many of our customers also use this to migrate their workloads from on-premises or other cloud into AWS. Lots and lots of customers use this. These are just some examples of how Malibu, as an example, have benefited, where they can recover in minutes as opposed to hours. And also, of course, TransDev, they reduce their cost by 73%. So I want to walk very quickly with an example of how much would it cost CloudEndure. So let us assume that you have 100 servers, 200 volumes, 10 terabytes of data at source, and then 30% monthly change rate. Based on this, approximate cost would be $3,400 per month. And I have given the cost breakdown as well. The CloudEndure license cost is basically cost per VM per month. And then there is staging area replication server, standard EBS storage cost, and then the snapshot cost. Altogether, $3,400 per month. That comes down to like ballpark $34 per VM protected per month based on these assumptions, right? So which is approximately $410 a year, which is worth protecting considering that the cost of downtime and the risk of losing the brand reputation in the event of a ransomware attack or a disaster if your applications, mission critical applications, go down. So with that, I want to switch the presentation to VMware. How can you achieve disaster recovery using VMware Cloud on AWS? Rick, do you want to unmute yourself?
Yeah, of course. So first, I'm going to do a quick intro of what VMware Cloud on AWS is, just to level set the service that we have. So VMware Cloud on AWS is a service that was jointly engineered between VMware and AWS. We are able to run vSphere and its code, the same code that you might use on premises on AWS's global infrastructure. So here on the left side, we have the on-premises environment, which is what you probably are using. We have AWS's global infrastructure, which is what we are using. On top of that, we run the code for vSphere, vSAN, and NSX. We have vCenter in this environment to manage those components, and we can link them up in a single pane of glass to be able to manage both environments from a single interface. We also, because we are on the AWS global infrastructure, we have native access to AWS's native services to augment VMware Cloud on AWS service. Okay, let's go to the next slide. Now, we have several use cases that we see very often with customers. These are the most common ones: cloud migrations, which is if you're closing down a data center, you can migrate your whole environment to VMware Cloud on AWS. Data center extension, which means if you need more resources, you can quickly expand that footprint into VMware Cloud on AWS, and then you can contract it back to your data center when you don't need it anymore. And what we're going to focus here today is disaster recovery scenarios. We also have modernization phase. One more thing I like to mention about the service is that it is managed by VMware. What this means is that all patching, all updates, all upgrades are done by VMware. So you don't have to be managing vCenter, vSAN, NSX, any of that anymore. VMware takes care of those updates for you. Okay, so now let's focus on disaster recovery. So we have two offerings for disaster recovery on VMware Cloud on AWS. The newest one is VMware Cloud Disaster Recovery. If you can build the slide up. This option, or for this option, much like CloudEndure, we are replicating over to a scale-out file system. So we're just using storage. We don't need the compute portion of the disaster recovery site unless there's a disaster. We use this for moderate RPOs. It's 4 hours, what we normally stage that for. And then our other option, VMware Site Recovery, which is Site Recovery Manager, if you've used that on premises. It's the same product, it's just a managed version of that. We use that for low RPOs, less than 30 minutes. It can be down to 5 minutes if you guys decide to do that. The only detail with this one is that we need VMware Cloud on AWS environment up and running to be able to replicate into. Okay, now let's look a little bit more in detail on these two services. VMware Cloud Disaster Recovery, which is the first one we talked about. We would install DR as a service connector on your on-premises environment. This is just an OVA that you would go ahead and install that connects to vCenter, and that gets access to your VMs. There are no agents that need to be installed on the VMs. This is completely transparent to the VMs. It'll go ahead and do snapshots and start replicating those into the scale-out file system as needed. Whenever there is a disaster, there can be a trigger to build a new VMware Cloud on AWS environment that gets stood up. Once that is ready, VMs can be powered on from where they are on the scale-out file system, and then you can do a live vMotion from that over to the VMware Cloud on AWS environment. So again, it's on demand because we can do live mount. There's a pilot light option. What that means is that we can have that VMware Cloud on an AWS environment already up and running and configured with a minimal footprint to make recoveries faster. It's VMware, so there are no conversions between on-premises and here. It's all native VMware VMs. Let's jump to the next one. Now, on site recovery, the difference is that, again, you have a VMware Cloud and AWS environment already up and running. You are doing continuous, well, it's not continuous, it's also snapshot-based replication on the back end. They're making headway into getting it to continuous replication. It's not there yet. It's still tagged as snapshots. And it replicates all those VMs depending on the protection plan that you have. You can have the DR runbooks to order the VMs for which to power on first and which after. This can also do IP changes on the fly of those VMs on the recovery site. So if you build it up a little bit afterwards, so what this would entail is removing your need to having a DR site because we are using VMware Cloud on AWS. Now, this VMware Cloud on AWS environment can be not only for site recovery, but you can also use it for other workloads. Because we are using only the storage portion, the compute and memory are not actually being used by these VMs because they're powered off. They're just being replicated over. You do have the option of running additional workloads on this as long as the storage permits to be able to do dev test or other workloads in the environment. Now, an example here, Discovery Channel, one of our customers, they had an on-premises DR site, which they had a lot of trouble with. They came up with site recovery. They turned it on, tried it out. If you continue to build a slide, they were able to do some end-to-end DR tests and came up with 12 minutes end-to-end failover time instead of what they had before, which was totally inadequate for their needs. Now, let's go a little bit over the costs, just for sake of comparison. So again, 100 servers, 10 terabytes of data. 30% monthly change. On VCDR, we are looking at a total cost of about $3,600, $3,700. VCDR is charged by the VM and then how much storage it's using on the back end. The VM is the cost that includes all the infrastructure that's on the back end that we don't have to pay for to make the service happen, and then turn on and move the VMs and all of that good stuff. Site recovery, it looks a lot more expensive, but as I said, we do need a VMware Cloud on AWS environment up and running, and that gives us a lot more than just dumb storage to which you're writing. So you have that environment up and running. For example, this one with 10 terabytes of data used and 100 servers. If we continue on servers of this size, we could put around 70 more servers on that environment and run them without any additional cost. The site recovery cost is made per VM, and that includes the licensing. Total cost of the whole environment is $16,000. Now, again, as I said, you have 70% more of what we're saying here, resources available that could be done, could be used for dev test or whatever else you guys need.
Thank you, Rick. This was great. Great insights into the VMware technologies for those who prefer to continue to use VMware in AWS. So to summarize today's discussion, right, the benefits of hybrid cloud disaster recovery is, number one, most important, you want to protect your brand reputation by making sure that we are not in the bad news, right? If a ransomware infection happens, let's try to quickly recover back to a pristine point in time by leveraging the infinite scale of cloud by recovering really very, very quickly into AWS cloud. We want to also reduce the risk of revenue loss because of application downtime. Could be because of man-made disasters or natural disasters. Either way, we don't want a very large application downtime. Definitely want to reduce costs so that you can pay as you grow. You can grow and shrink your infrastructure within minutes. Everything should be API-based. Definitely want to totally eliminate expensive hardware refresh costs so that you can consume on demand and pay per use. And last but not the least, let's eliminate the undifferentiated operational burden, right, of managing the infrastructure and instead reallocate our time for more productive activities. Let managed services like AWS and or VMware take care of that operational burden of managing the infrastructure. That's what we had today. As a follow-up, let's chat soon. If you have a project, if you have needs, let's reach out to your AWS account team, and then we'll be very, very happy to help you.